Welcome to Unit 1, Lesson 2, Reflections and Stretches, Part 2, Vertical and Horizontal Stretches. So in the last video, we looked at how the negative or positive value of either the x's or y's caused a reflection across the x or y axis. Now we're going to look at how the values of a and b affect the shape of the graph. So if you look at your notes, you can see here we have an explanation of the vertical stretches. This is when y is equal to a times f of x. So on the right here, I made a table of values to reflect the graphs that are a little bit lower down. So the graph is stretched vertically by a factor of a. That means that whatever the x values are, the value of a is going to affect the y values. So at -3, if we have y equals f of x, we'll have 9. If we go to y equals 3 f of x, the coordinate would be -3, 27. And if we go to y equals 1/3 f of x, the coordinate would be -3, +3. So there's some general rules for us to follow. The first is, if a is greater than 1, the values of y are multiplied by a factor of a. So for example, y is equal to 3fx, the values of y are multiplied by 3. So there's an example of that here in this column. Okay. The other situation that we can have is that the value of a falls between 0 and 1. So basically, if it's a fraction, then the values of y are still multiplied by a factor of a. For example, y is equal to 1/3 f of x, which is shown in this column here. Keep in mind that when you're multiplying by a fraction, if you were doing this in your calculator, you would just go 1 divide by 3 times the x value, -3, and that would give you this output. Don't forget that this line means divide. So whenever you have a fraction, you can just go ahead and divide the two numbers and then multiply by whatever's attached to it. Now, it's shown in this table, but what happens to our graph? How does our graph change? So we have that base function f of x equals x squared, or y equals f squared, and x squared, sorry, and that is this red line here, the middle line on your graph. So here's our y equals f of x. Now, when we're looking at this function, y equals 3f of x, we can see that for every value of x, the y values have tripled. So for example, here we have coordinate 1, 1 on our graph. On the y equals 3f of x graph, that coordinate is 1, +3, right there, as shown in your table as well. Now, on the y equals 1/3 f of x, all the y values are going to be 1/3 of what they used to be. So we take that same coordinate again, 1, 1. What's going to happen is the x value will remain the same, coordinate 1, but the y value is now 0.333. So when it's vertical or horizontal stretch in relation to a in the formula, all you're doing is multiplying the function by that value to affect the coordinate size. Now there's an example at the bottom of a question that you see, which is 0.15 is on the graph f of x. Find the coordinate which is on the graph g of x is equal to 3fx. So from the notes above, it says that a is greater than 1. All we're doing is multiplying by the factor that's there. So our factor here is 3. All we're going to do is multiply all the y values by 3. So from our original coordinate 1, 5, x, y, our g of x function would be 1, 15, and you can see that it's a vertical stretch by a factor of. Now, the second type of stretch that we can have is a horizontal stretch. So just like previously where we could either move the graph left or right or up or down, here we're looking at operations done to the function that are affecting the x values, and that's going to shift it or stretch it left or right. We also have some rules here. The first one is if b is greater than 1, the values of x are multiplied by a factor of the absolute value of 1 over b. And what that means is that they are really divided by a factor of b. So for example, if we have y is equal to f3 of x, our b value equals 3. That means that our values of x are either multiplied by 1 over 3 or divided by 3. And as a general format, it would kind of look like this over here, x over 3y, or alternatively 1/3 x y. You can also have the situation where b is between 0 and 1, so in fraction form again. And in that circumstance, the values of y are multiplied by a factor of b. So if b is 1/3, 1 over 3, keep in mind that this 1/3 is going into the bottom of this fraction right here. So what you're really having is 1 over 1/3. Okay, and I'm going to talk about why we get to multiply by a factor of 3 down here. When we have a horizontal stretch, we have this value based on our example, x over 1/3 y, or 3xy. And this is why. When you are dividing by a fraction, okay, I'm going to try to simplify it down here to show you why that happened, but I'm also going to recommend this video. It's a 2-minute video, dividing fractions with keep, change, flip, fractions rap song. It's like a cartoon. I think that it'll get stuck in your head and you'll remember it this way. So check that out if this part doesn't make sense to you. Now, if we have x as a value of 1, 1 divided by 1 is still 1. So we'll note it as a fraction, even though we would never really note it that way, just for the demonstration of this. Now, we have 1 over 1 divided by 1 over 3. So it kind of looks like this if we wrote it out sideways. Now, what you do following this keep, change, flip rule, the first one is kept, okay, keep, change, flip. Keep, change, flip. So we keep the 1 over 1, we change the sign to multiply, and we flip this one to 3 over 1. Now you just multiply across. 1 times 3 is 3. That gives you that number there. 1 times 1 is 1. And then, of course, 3 divided by 1 is 3. So if you're wondering why it's changed to this, this is the reason behind it. But if you just remember the rules that are given further up here, if b is greater than 1, divide by the factor. If b is between 0 and 1, multiply it by it, then you would be successful. Now on your graph, again, sorry, I missed labeling it. This is our y equals f of x. This one is our y is equal to f of 3x. And the big wide one is our y to f of 1/3 x. So you can see if b is greater than 1, then your graph is going to get tall and skinny. If b is less than 1, it's going to stretch out and kind of become fatter. Okay. Now, at the bottom of the page, we have a couple more examples. So the first example is similar to the one on the first page, which is just looking at how does b affect it. So the 0.53 is on the graph f of x. Find the coordinate, which is on the graph g of x is equal to f times 1 over 5x. Now, b is 1 over 5. Okay. Based on the rules you see further up on your page, 0 is less than b is less than 1. B is between 0 and 1. Therefore, whatever number's on the bottom here, we're going to multiply all the x's by that value. So our original xy coordinate is 5, 3. All we're doing is multiplying the x's by 5 to give us 25, 3. That's our new xy coordinate. The second example that's given here is showing both a horizontal and vertical reflection happening. So the 0.29 is on the graph. G of x is equal to 1/3 f times 2x. Now notice that we have both a and b in this formula, and that's okay. Don't get stressed out. Just break it down into really small steps to be able to find the coordinate, which is on graph f of x. Now, let's just start with our a. Our a is equal to 1/3. Our a values, all we're doing is just multiplying by whatever's there. You don't have to remember any extra rules. So whatever you have, you just multiply your y's by that value, which is 1/3. Don't forget that multiplying by 1/3 is the same as dividing by 3. Okay, so you can see that our original values are x, y. Our y values are now divided by 3. In the second part here, b is equal to 2. And from our rule above, what we will do is multiply the x values by 1/2, or also known as dividing each value by 2. So you can see here our x goes to x divided by 2. All you have to do is just take what it says to do in these brackets here. 2 divided by 2 gives you 1, and 9 divided by 3 gives you 3. So your new coordinate would be 1/3. Super simple and straightforward. Don't overthink it. Just go by the rules that you've been given, which are only 4 so far. So h minus h is a horizontal shift left or right. It moves your graph. K also moves your graph up or down. A stretches your graph. And B makes your graph skinnier or fatter. Here are some examples just based on using the base function x squared. So we have g of x is equal to 4f of x, and you can see x squared is our red line there, and 4f of x our blue line, and the same thing here. Those are just some examples you can look at. Remember the content. Now, you might also be asked to determine the equation of the transformed function. You might be saying, oh, how the heck would I do that? I don't know the equation for this function, but that's okay because we can figure it out. So it says the graph of the function y equals f of x has undergone a stretching or a reflection. Determine the equation of the transformation g of x. So our f of x is here. It's just that nice x squared graph. We'll use that parabola shape. And our g of x is here. You can see it's skinnier and the y values are increased. Now we can figure it out in relation to the y values, and we can also figure it out in relation to the x values. So I'll give you the explanation with the y's first. That's why we have two different explanations here and the different notation. So if you look on the original graph f of x, we're going to be using this point here, which is 2, 4. And we're going to compare it to the point on g of x that is at the same x coordinate, but we need to figure out what's the new y coordinate. We look at this one, it's 2, 16. Now, our x's are the same, our y's are 4 times greater. So therefore, a equals 4. Because if you remember from the start of the video, when we have our a value, all we're doing is just multiplying by that factor. So if you see here, it's 4 times bigger. You just have to think, what happened to the 4 to get 16? Well, I multiplied it by 4. That gives you your a value. And then you can just express it this way. G of x is equal to 4x squared. So the other way that we can look at this is by using our x values. We have this point here, 2, 4. And on g of x, that value has shifted and it is 1, 4. If we have this value, we're going to do the exact same thing, and we're going to see what happened to the x to make this change. So our original function f of x, we have 2, 4, and our new function g of x, we have 1, 4. Our y's are the same. Our x's are divided by 2. And that value, that change in the x values is our b. So our new coordinates will be x divided by 2, y to get this g of x. And therefore, g of x is equal to 2x squared where b, the value of b is given. Now remember, b is that 1 over b, so it's reflected here. What you have to do is put that bottom number in for b, and that will tell us to divide by it.